Hi everyone, this is some quick notes on probability and distributions. So I'll do it in small sections. I've covered this already in class, but many of you weren't there. Um, First of all, I think you all know intuitively what a probability is, but the notation that we use is P for probability is capital, and inside here, this thing here is whatever the event that you are interested in of happening. So, for example, you could use words like, what's the probability of rolling, or what's the probability of me picking Hassan on a team or something like that. I could just kind of write it out like that. Or what's the probability of rolling a 6, something like that. As long as we know the context, I understand what you're trying to say there. And a probability is calculated, so probability of event A, they'll often use A, B, C, D. Probability of event A is out of the total number of things, which is, we write it like this. So if you count all the possible outcomes, that would be this. So N is the number of things, number of events or things. What things do you speak of? Again, the brackets is to explain to you what are you counting. U, by the way, is called the universal set. So it's all things. So it's kind of a fancy way. Some books, instead of using this, will use capital N. So something like that. And then the number of things that contain whatever A is. So something like that. So it's just really, really simple. I think without even this description, you'd know what I mean. A couple of rules about probabilities. Probability of any event can only be between 0 and 1. So we use what's okay to write. You can use fractions. You can use a decimal, which is the most common. But to speak to normal people, usually we talk about percentages for probability. But the most common one is decimal, and that's what I'm referring to when I say between 0 and 1. So 0% to 100%. So there you go. That's a couple of things there. So if you look at some of these simple questions here, if you zoom in a little bit, letters picked at random from the letters of random. Calculate the probability that this letter is from maths. So how would I write that? Probability that it's from maths. You don't have to kind of be that pedantic, but there you go. So how many letters do we get to pick from? 1, 2, 3, 4, 5, 6. There's 6 letters in random. And how many of them are in math? Let's see here. You got that one. That one's there. That's it. So you got 2 chances out of 6. Something like that. I think I got that right. And then I would simplify that. Although if you don't, it's not the end of the world. 2, a dartboard has 20 sectors of equal area. Is that true? Oh, I see what they're saying. Yeah. If a dart lands on the number sectors at random, find the probability that the number is at least 4. So probability that it's at least 4. Well, there's up to 20. So you could just write something like at least 4, or if you wanted to, you could write it like, it doesn't really matter how you write it. Like technically, it's between 4 and 20, right? Because it can't be beyond 20. There is nothing. Either way, that doesn't matter. That's just the naming convention. So it's 4, and then how many things are greater than or equal to 4? I believe there's 17 of those. Another way to think about it is 1, 2, and 3 would be no good. Those are the only 3. So things like that. It's pretty straightforward, I tell you. It's not that I can, I don't know. Which one can I do? What's the probability that it's prime? Well, what are the prime numbers? Oh, this is a trick question. I think some of you would make a mistake, because what are the prime numbers? Think of them for a little bit. If you counted 1, it actually technically is not considered a prime number. Used to be back in the 1700s, but not now. So that was just a little definition thing. So prime numbers is, let's see, from up to 20 is 2, 3, 5, 7, 11, 13, 17, 19. I think I counted 8 of them there. So 8 out of 20. I think that's what it is. And then you can simplify again. If you don't simplify, it's not the end of the world, but it's nice if you do. And again, like I said, you could turn it into a decimal, or if you wanted to, this. It's just what you want. Okay? Right. Let's see what else we got here. Complementary events. That's the probability that something does not happen. So basically, that would be listed of the probability that A does not happen is listed like this. So it's this symbol here. It's this bit here. That's the not. That means not. So I would read that as probability of not A. So one way to write it is probability of A plus the probability of not A should always be equal to 1. And you could rearrange it in any form you want. They just rewrote it like that. Doesn't matter. Same thing. Let's look at some of these questions. Now they got some tables here. Which one looks fun? They all look fun, don't they? Yeah, let's just pick the first one. So surveys carried out. Shoppers were asked about how they traveled that day. The results are shown in the table. So there you go. One shopper was randomly selected. Find the probability that this shopper traveled by car. So probability that it was by car. You can write C or car or whatever. So how many are in cars? 73 out of how many? Well, you got to add all those up. Did they add that up for us? No. Oh, such a pain. Okay, to the calculator. So 40 plus 59 plus 37 plus 33 plus 41 plus 29. 239. I think. Okay. Hope I got that right. Yep, feels right. And then you can turn that into a decimal. I don't care. B, find the probability that this male shopper traveled on foot. Oh, one male shopper was randomly selected. Find the probability that this male shopper traveled on foot. So probability that... Now this one's interesting because it's essentially what's called a conditional probability. I'll point it out, but it'll come up shortly. So how do you write that? Find the probability that this male shopper traveled on foot. So you could just write on foot, right? Something like that. But if I just looked at that, I would think that it's anybody. But this is only the male ones. And how many males are there that were kind of surveyed? So it's only out of the surveyed ones. And that's called if you're limiting to who you're looking at, it's called a conditional probability. So do pay attention to that because that'll be important. So it's out of 136. And then you can, again, turn that into that. The real way to do that is, this is interesting, conditional probability. And the way you write it is like this. So you're looking for the probability that somebody is on foot. And then you write a big line here and you say what you already know. You know that they're male, like that. And there's a little formula in your formula booklet for this. It actually, it can be simplified to, you look for the probability of that they're on foot. And male divided by the probability that they're male. So you could do it like that. But it's the same thing as if you just do the count of foot and male. That's not in your formula booklet, this part. Divided by the number of people that are male, like that. But this piece here. That's in your formula booklet. So neat. Again, I think it's intuitive. C, 1,300 shoppers visit the town in 1 week. Estimate the number of shoppers who traveled by bus. So what you do is, for this one, again, they're skipping ahead to a lot of problems that they'll mention again, but the probability that, let's see, estimate the number of shoppers, not a probability I'm looking for at all. So how am I going to do that? Number of shoppers. How am I going to calculate that? Well, what I'll do is I'll figure out what the probability is that somebody is a shopper that is traveling by bus. So bus people, there's 100 out of a total of 239. That's kind of statistically what I'm expecting people on bus, times the number of visitors they get. And this would give you your number that you're looking for. So since I have my calculator here, I'll do the calculation. So it'll be, I'm expecting 543.9, so I'll say 544. 3 significant figures. So that's how I would do that. Okay, I'm going to stop here. We'll continue on the next video.